Hello and welcome to this video. In this video, we will study collision resolution techniques and a simple program on hashing. So before we get started, if you are new to the channel, then please subscribe to the video, subscribe to the channel and make sure you press the bell icon to receive notifications on upcoming videos on this channel. I make videos on data structures using C, that is this playlist, and plus I make videos on Python and Rust and also on class 12 mathematics. So these are the four playlists currently that I'm making videos on. Other than this, I already have a full playlist of C programming which you may watch depending on your comfort with C. So without further ado, let's get started. In the last video, we discussed how hashing can lead to collisions where an element whose hash is computed, the hash function can give same hash value of two different inputs. So this is solved by two different major ways. One is called separate chaining or open hashing, and another is open addressing or closed hashing. Open addressing is of three types. One is linear probing, second is quadratic probing, and third is double hashing. So we will look at them one by one. Remember that in practice, no matter what hash function you choose, there is always guaranteed to be collisions. There is no good hash function. This problem is so severe that GCC's map uses red-black tree as a backend, which I have said earlier in the video as well. The argument in GCC's documentation is because of collision, the search time worsens to order of log n, and the red-black tree is guaranteed to give you order of log n search. That is the time complexity of red-black tree. That's why they chose red-black tree for the sake of simplicity for implementing C++ MAT data structure. Now in separate chaining or open hashing, each cell of the hash table points to a linked list of records that have the same hash function value. So suppose our hash function is x mod 5 and we input values like 12. So as you can see, these vertical bars represent a cell. So we have 1, 2, 3, 4, 5, 6 cells, although there will be 5 cells actually. 1, 2, 3, 4, 5, 6. Yeah, there should be 5 cells for mod 5. So when 12 comes, it will occupy the third cell because 12 modulus 5 is 2. So 0, 1 and 2, third cell. Then comes 16. So 16 mod 5 is 1, it will occupy the second cell. Then 22. 22 has the same hash value as 12. So it will occupy the next position on linked list in the same cell. The cell will point to the linked list. Then comes 25. So 25 the modulus 5 is 0. So it will occupy the first position in linked list. Then 35 and 45 will occupy successive positions on the linked list, and 63 will occupy the fourth cell. So as more values will come in, they will occupy either a cell or a position on the linked list pointed to by the cell. The second technique, which is of open addressing and closed hashing, is linear probing. So in this case, next slot will be taken. So for example, hash function is x mod 5. 12 comes in, 12 sits at place cell 3. Then 16 comes in, so it takes cell 2. Then 22 comes in, now it sees that I should be sitting at cell 3, but since cell 3 is already occupied, I will take the next position, that is the fourth cell. Then 25 comes in, it sits at first place. Then 35 comes in, it looks that I should sit at first place, but it is filled, second is filled, third is filled, fourth is filled. So I will go and sit at the fifth place. That is how you do linear probing. The other concept is that you do quadratic probing. If hash x percentage modulus is full, then try hash x plus 1 square. If this is not available, then try hash x plus 2 square. And then try hash x plus 3 square. This should be square, not cube. And so on. Then the last technique is double hashing. In this case, you have x comma y. So you compute the hash of x. Okay, if it is available, you make use of it. Y is the non-negative collision number. So if it collides with hash function of x, hash 1 of x, then you use another hash function of x along with the collision number and then take modulus of that and it goes to that place. So this technique is called double hashing. All these techniques have their pros and cons in terms of computation and efficiency and distribution. But as you will progress further, you will know which methods are better. As you will, the best way to understand this is by studying the popular hashing functions, and that will let you, that will make you understand uh, that which hash functions are written with what purpose in mind and how they are superior or inferior to each other. So it depends on what kind of hash function you choose and what is their applicable area. Based on that, the quality of hash function is determined. So since this is done, we will go and look at the program. It is called index mapping. It is very simple. It is so simple that it is called trivial hashing as well. So we have 3 header files which we need. We have a hash table size of 1000 into 1000. So this hash function can contain 1001 into 2 such columns. That is, it can contain 2002 values. Okay. Now it takes an array as input and number of elements of that array. Now what it does is, if the AI is greater than 0, then it sets hash of AI and 0 as 1. Otherwise, if it is negative number, then it computes the absolute value of that and puts in the column number 2, that is column number 1. Okay, so first column is 0 and second column is 1. So first column can accommodate values up to 0 to 1000 and second value can accommodate the value minus 0, not minus 0, 0 to 1001. Since there are 1001, 0 to 1000 both columns can accommodate. The second column accommodates negative values. Now to search, when you search a value, if it is greater than 0, it looks at the first column, and if that is true, it returns true, otherwise it returns false. But if x is negative, then it computes absolute value of that and looks in the first column. If it is found, it is true, otherwise it returns false. It is a dead simple program of hashing. Let's see this in action. Now for the driver program, I have included -1, 9, -5, -8, 5, -2, -20, 25, 45, 28, -33, 78, 67, and 96. So let's run this. GCC controller GCC, and we give our usual switches, wall w error minus std is equal to C11 minus pedantic. So it compiles successfully. So it asks for a key to be searched. We give -20. It says yes, it is in table. We look for, say, 67. It says yes, it is in the hash table. Now we want to find a value which is not there, for example 70. So we give 70, it says the key is not in the table. So this is how index mapping or trivial hashing is implemented. I don't think it needs further attention or further discussion, because it is, first, it is so simple, second, it is mostly useless. Other than for integers, it is useless, and that too, depending on the highest value, the size required is twice of that, but that's justifiable because it stores negative values also. So I will end this video here, and in the next video I will come up with the more involving program on hashing, and we will continue this series of data structure algorithms. I hope that you have found this video useful and informative. Please like the video, share it on social media, and make use of comment box to interact with me. I would definitely like to interact with you guys because some of you may be veteran programmers and some of you may be new, but you might have some unique thoughts, some original thoughts which I would like to understand and implement this in series. So thanks a lot for watching. Happy programming.